Let's record so that if I can figure out how to tape this thing, we'll be in good shape. Okay, so I'll put this, let's see if I can make this a little bit smaller, just so it doesn't take up too much room. Okay, so the question was about type 1 and type 2 errors. So the whole idea behind type 1 and type 2 errors, and I think type 1, there we go. Question 5 was the first question. Okay, so the thing you want to remember about a type 2 error is that, or type 1. So the type 1 error, okay, where's my little doohickey, make it easier. Hang on a second, there we go. Okay, the type 1 error, it is the risk that you are willing to take that you will reject the null hypothesis when it is true. Now, what does that mean? That means that you will reject status quo. I think of the null hypothesis as status quo, meaning it's the way things are, and it's everything's going theoretically the way it's supposed to. Okay. When you reject that notion and you say, well, my sample showed something happening, then you're saying that, okay, now I need to look at this a little more detail because we're not going to keep going at status quo anymore. We're going to do something different. So type 1 error is when you reject the theoretical, the status quo, in favor of the alternative, which says something happened, something's greater than or less than or whatever, but you were wrong. So status quo should have been kept, but you went off the other direction. That's a type 1 error. Does that make sense?
Yes.
Okay. A type 2 error is the revert. So let me give you this in terms of a jury trial. Okay. A type 1 error is when they say we're going to reject the innocence of the person and support the statement that that person is guilty, when indeed they're really innocent. That may be an easier way to think about it.
Yes, that is.
The type 2 error, on the other hand, is when you fail to reject the null hypothesis and it's really wrong. Okay, so you fail to reject the status quo in favor of the alternative. So for our jury, you say the person's innocent, but they're really guilty. That's a type 2, you've made a type 2 error. Does that make sense?
Yes.
Okay, so for number 5 then, okay, so for number 5 it says they wonder if the average water temperature of streams without tailed frogs was different than the average water temperature for streams with tailed frogs, which is known to be 12.2 degrees, okay? So they want to know if it's different, which is following is a correct statement. So first of all, which are known to be 12 points. Survey of 31 streams without tailed frogs was taken. Water temperature core, which of the following is a correct statement of the type 1 error. So HO is that the temperature of the stream is 12.2. H1 is that it is different from 12.2. Okay? Now, the claim is that it's different. Okay? So researchers, so that what we're saying is they found evidence that H1, but it's really true that HO is true. So now we got to figure out which one it is, and it's D. Researchers found evidence that the average water temperature without tail frogs is different. See, that's H1 of the stream with tailed frogs, when really there's no difference. This is HO in the water temperature. That's why it's D.
Okay, yeah, that's
That
good.
makes sense?
Yes.
Yeah, you just have to work your way through those things, unfortunately. Okay.
Thank you.
So this takes us to what Rebecca was saying, and then the next one is, this is a type 2 error, and a type 2 error is when you reject the null, but you shouldn't have, and that's B. Cameron did not have evidence, so there's you didn't have evidence that there was a difference. Okay, so that's, you failed to reject the null hypothesis, but there really was. That's a type 2 error. Okay, so I think the best thing I can do for you is to do some examples of hypothesis tests, and I'm going to pick one of these that has multiple parts, if I can find one. Let me see here. I think I'll go back to, here we go. Yes. Okay, so there's a good here's a good one. Okay, number 3. So here's the catch to all of this. Okay, you have to start out with, you have to look at and find the claim. So what are they claiming? Okay, so I look at this and it says 49 subjects, so N is 49. Cholesterol levels are measured before and after treatment. The change of their cholesterol levels has a mean, so this is the mean, X bar, and a standard deviation. Okay, this is all has to do with the sample, and a 0.01 is significance level. I want to test the claim. So here's the claim, that with garlic treatment, the mean change is greater than 0. Okay, so it changed greater than 0. So that's my claim. And so my claim is that mu is greater than 0. So where do I put it? Okay, so here's the rule. And what I suggest to my class, my ground class, you go through these 5 steps regardless of what the question's asking for, because you really need to know the whole picture in order to answer even one part of the question. And so the first step is to state the claim. They give you in the textbook like 8 steps. I've got it down to 5. So the first step is to state the claim. The second step is this, and the rules for this are this. The only thing you put in H1 is either a greater than, a less than, or a not equal. And the HO in that case is always equal. Okay? If the claim is equal, then you put it in here, and the H1 is not equal. Okay? So here we have a claim that is greater than. That means I have this one here. Therefore, I will put it in H1. So the only one that works for this is C. Because you put, and I'm going to make a note that that is my claim. So my claim is in H1. That's very important. Okay? Now, Rebecca, you wanted the test statistic. So in order to find the test statistic, okay, what you're going to do is you're going to use your calculator. Okay, I'll leave it over here. And let me turn it on. Okay, and clear. Clear. Okay, so this is a means test. A means test is under stats. Now, tell me if I'm going too fast. Test, and the means test is the t-test. Because the only time you could even consider using the z-test is if you know the standard deviation of the population, meaning you are giving sigma, or somehow the problem tells you that you have the standard deviation of the population. Then you can use number 1. Otherwise, for means testing, hypothesis testing, you will always use 2, the t-test, okay? for proportions, you're always going to use this one, number 5. Okay? So, t-test. I have stats. I don't have data. If I had a bunch of data, I would put it into a list and I would use data. Because if I choose data here, okay, if I go data and say, okay, what they ask for is altogether different. So I choose stats, okay? First thing it asks for is mu0. Mu0 is whatever the number is that is in the hypothesis test, okay? So in this case, it happens to be 0. The next part is X bar. So I go up there and I look. The mean is 0.7. I put in 0.7. The standard deviation is 18.6. And N is 49. Now, you can do the test statistic and use the formula for it, but if you use the calculator, you don't need to. Now, very important part of this line that I'm on now tells me what the alternative looks like. And in my case, if you look at what I have here, okay, I have mu greater than 0. So what I need to do is I need to come over here and make sure you press enter, because if you have one of the other two highlighted, when you calculate, the test statistic will come out correctly, but the p-value will not. Any questions on what I put in there and how I did it? Rebecca? Ooh, Rebecca, if you're going to use a calculator, can you borrow one from someone or something? I don't want you to go out for the last couple of weeks of class and buy one, but can you borrow one from a friend or someone that you know that you can find that has a TI 83 or 84 calculator? This is an 83. The 84 is a lot better, but the 30, you're going to have to use the formulas. And it just takes an awful lot of time. Is there any chance you can borrow a TI 83 or 84 calculator from someone? I'll go through the formulas with you. Matter of fact, if you can't get a calculator, Rebecca, let's make an appointment to just work together, and I'll work down through with you on how to do it. Okay, so let's email me and let's make an appointment to get online like this, and I'll walk you through the formula method. Okay. So there's the value. Okay. Now, if you're, let me see if I can find so anyway, there's the test statistic. So T is here. It's 0.2634. Okay. And they want it rounded to 2 places. And then the p-value is 0.39. Rebecca, have you been able to use the, with the p-value, oh boy, the p-value is really difficult to calculate without trying to think how you can calculate it without a, I have to think about that. Because the table only gives you critical values. It doesn't give you p-values. Well, for the most part, we'll work on that. Anyway, so the p-value is 0.397. Excel, yes, Excel will work. But I don't think they let Excel into the final exam. That's my concern. Because I could give her the Excel functions. I could give her the Excel functions easy enough, but I don't believe they allow Excel on the final exam. That's why I've been doing the calculator thing. Okay, so let's get to the part about formalizing the last statement, okay? So once you have a p-value, and Rebecca, you can actually, you may not get the p-value, but you can actually do it by a critical value method, which you can use the tables for. So that's another option that you have. That's why I said I think we need to get together, just you and I, and go over that part of it. So this part, all of us can agree to. Once you get the p-value, okay, so here's the rule for the p-value, okay? So this is step 2, this is step 3, this is step 4, and the rest of step 4 is this, okay? And this regardless of how you calculate it. So if the p-value is less than or equal to alpha, and in this particular case, alpha was 0.01. Okay, the significance level, that's what alpha is. So if that's, you reject the null hypothesis. If the p-value is greater than alpha, you fail to reject. Okay? So in our case, we have a p-value of 0.39. So we have 0.39, and the alpha is 0.01. So it's definitely greater than. So we will fail to reject. Okay. Now the piece that everybody has trouble with, and I posted it to the website, and let me see if I can pull it up. Let me see. Where's my? Let me see. Where did I put that little doohickey one sample? There it is. No, that's not what I wanted. That's not what I wanted. It is the wording of the conclusion. Okay, here we go. So, and I posted this, and you should copy it down, and you should definitely have a copy of this while you're working on your homework and your quizzes, so that you learn how to answer these questions. So the first question is, does the original thing contain, let's see, draw. Does it contain a condition of equality? That means, was your claim mu equals something, whatever the number is, okay? If it does, then you go this direction. If no, our mu was greater than 0. So we're going to follow this path down, okay? Did we reject HO? No, we did not. We failed to reject it, so we're here. There's the final answer. There is not sufficient sample evidence to support the claim that, and that's where we come back to the, go back to my mouse pointer, photos. Okay, now we come back to our problem, and step 5, we simply say that there is not sufficient evidence to support the claim, and the claim, the claim that garlic treatment mean change in LDL is greater than 0. Questions? 5 steps. You have to memorize this piece, and you have to memorize this piece. And you have to also pick up that last part. I don't know, I must have closed it out. I didn't mean to, but I did. Okay, but it's in our thing. So what can I explain further? I'll do another problem, but where are we at?
That helps.
Shall I do another problem?
Maybe one more.
Okay, I will do another one. Okay. All right. Nice. Let's see what we got here. Let me do a proportion one. Let me see. Okay, so I'm going to, I'm first gonna give you, okay, I need to get rid of these things. Okay, so these are my 5 steps, okay? Those are out there, so I don't care. Draw. Okay, step 1, the claim, and write it in math. So the claim is going to be whatever the statistic is. I'm just going to put stat here because it could be P or it could be mu. Either is going to be greater than, less than, equal to, or not equal to. Okay, that's step 1. Step 2, do HO and H1. Okay, put the claim first. If the claim is less than, greater than, or not equal, write the claim here and label it as such. If the claim, and then make this, whatever it is, equal to. If the claim is equal, put the equal in first and label it as the claim, and then the alternative will automatically be not equal. That's step 2. So far, so good?
Yes.
Okay. Then, let me go on to another page here. Okay, this has got to go up. Oh, it just writes on the page. Okay, so, oh, I see what happened. Okay, so step 3, I'll put it over here. Draw step 3. Step 3 is the test statistic. Okay, and you got a formula for that, or you're going to use one of the functions. Step 4, I'll put that up here. Step 4 is to reject or fail to reject. Now, there's 2 ways to do it. You can do it with the p-value method, and that is that if the p-value is less than or equal to alpha, reject HO. That's whatever HO is, whatever the equality is. If it is greater than alpha, fail to reject. If you do it by the other method, which is the critical value method, you're going to compare the test statistic to the critical value. If the test statistic is more extreme, EX, than the critical value, you will reject. If it isn't more extreme, so if when you draw this out, okay, if the critical value is here, it's what they call a left-tailed test. If the critical value is here and the test statistic shows up over here, then you would reject the null hypothesis. If, on the other hand, the test statistic ends up over here, you would fail to reject the null hypothesis. Okay? So that's the process which you go through, okay? And then step 5 is that flow diagram that I showed you. Anything that needs more explaining in the general concept?
No, this has helped a lot. Thank you, Professor.
Okay, good. Okay, so let me go back here to the mouse, close this down. Don't save. That's what I was afraid of. I kept all of that writing up there, so now I have to erase it all. The heck with it. Okay, so now let me find a problem that I can use. Okay, this one already has the calculations done for you. I've got to take a look at the final, Rebecca, and see whether you can get away with, you may be able to get away with that. Okay, so let's see. I need to erase most of that part I don't care about. I need to get rid of this stuff so we can read. Okay, suppose 242 subjects are treated with drugs. So we got 242. Okay, let's see. 242 treated with drugs that are used to treat pain. 53 of them develop nausea. 10% is the significance level. We're going to test the claim. See, here's the claim. More than 20% of users develop nausea. Okay, so does it make sense? So what would you say is how would I write the claim? Which one of these, A, B, C, or D, is the, I'll try to erase some of this stuff here. Which one of those, A, B, C, or D, is the correct answer?
B.
Okay, you're correct. Because the claim is greater than, and the only one that's greater than actually is B, and then HO has to be equals. So that's what we picked, okay? Okay, so now we come down here, get rid of all this other stuff. Erase some of this junk, okay? And I would also be putting in here, I would make a note here that this is the claim. I would actually write, I would actually put a little C here, because when you get to the last step, you have to know where the claim is. So you're going to come back here and look and make sure you know. Okay, now you do the test statistic. So with the calculator, and Paul, are you using the calculator?
Yes, I am.
Okay, good. So the calculator, okay, so I turn this on. I'm going to use this time, I'm going to use a stats test 1 prop Z test. Okay, so the stuff is right there in the problem. PO is 0.2. So I'm going to put a 0.2 in there. Whoops, not a 6.2. A 0.2. How did I get a 6? That's just clear. There we go. Now, 0.2. There we go. That looks better. X. X is 53. N is 242. And the claim is greater than, it's already there, so I don't have to change that. And I calculate. Okay, so there's my Z score, my Z test statistic. Okay, it's 0.7, it says 2 decimal places, 0.74. My p-value is 0.2, once 3 decimal places, 0.229, so that rounds up, so it's going to be 0.230. Okay, and so the answer then, okay, then we get to the piece whether we fail to reject or what. Well, the p-value is 0.22 or 0.23, okay? And we look at our 0.23 and we look at our significance level, which is 0.1. So 0.23 is more than. So I come over here, it's more than, so I fail to reject. So my answer's got to either be A or C. The rest of it is step 5. So where do we put the claim? We put it in the alternative. And I went and got rid of that one, so I better bring it back again. Anyway, it's on the first page of the classroom, because I think I posted it for you. So I follow the path down through the outline, okay? And it says, well, if you put the claim in the alternative and you failed to reject the null hypothesis, that means that you didn't prove your claim. So the answer is A. There's not sufficient evidence to warrant support of the claim that is more than 20%. So does this help a little bit? How about you, Rebecca? Are you being able to follow it a little bit, or? So,
Yeah,
what do I need to go through yet?
Yeah, everything that you've explained, and then bringing the flow chart in, that helps a lot.
Okay, good. Yeah, you really study that flow chart, because that's going to be the key.
Yeah, just memorizing it, I think.
Well, yeah, it's memorizing it. It's really convoluted, because what happens is if the claim is equal, and let me see if there's a problem that's like that, that's equal. Yes, there is. Problem number 2. If I go back, I got to erase some of this garbage here. It's too much stuff on my paper here. My blackboard. Okay, so if I gotta go back to my mouse. So problem number 2. Okay, so yeah. So here, problem 2. Well, this one does all the calculations for you. Okay, so it says a certain drug uses a treatment for asthma. 21 of 289. So 21 out of that, there's your p hat. If you divide 21 by 289, you get the p hat, this number here. Treated subjects experienced headaches. The accompanying calculator display shows the results. Claim is, oh no, this is less than. Why is, when I did it, it was equal to. I'm trying to find one that's equal. Wait a minute. That one's, oh, it's A3 that I was looking at. Wait a minute, let me get, yeah, let me get A3 here, back up here. Okay. A2. Okay, this is the one. Okay, so here, this is where that little chart comes in really handy. So here's a summary statistics, okay? So they give you that, okay? Now, so we've got all this stuff here. I use a significance level of this, so we know what alpha is. And the key here is that the mean is equal to 3.75. So the equal goes in first, and the correct answer is B. Okay, so now where the flow chart is, the question is, where did you put the claim? And that's why I said put a little C next to it. The claim is now in the null hypothesis. The test statistic, okay, and I'll do that real quick. I'll get the test statistic up here. The test statistic, stat, test, z-test, stats, mu0 is 3.75. X bar is 3.67. S is 0.58. N is 84. Oh, shoot. What happened here? Clear. I lost my work here. I must have hit something. T-test. Start again. Okay. Dum, 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 dum. Okay, N is 84. And this now, okay, has got to be not, hit enter. I did not want to do that. Stat. My thing is getting too sensitive on me. Okay, here we go. This, enter. Now calculate. Okay. You see the t-value? Negative 1.26. Okay, so if I picture this on a, let me make this smaller. Okay, so if I picture this on a continuum here, okay, my t-value here, this is a z standard normal curve. My t-value is a -1. My z-score is a -1.26. Okay, the p-value is 0.20. Now I'm comparing this against a 0.01. So my p-value is greater than 0.01 because it's a 0.2. So therefore, I failed to reject the null hypothesis. Now, if you follow that path, you put the claim in equals, you failed to reject. So the answer is not the same. You don't word the answer the same way. You say that there is okay, you failed to reject. There is not sufficient evidence to conclude that the original claim has a mean population of this. Or you state that it doesn't warrant rejecting the claim that. So in other words, you can't reject the claim that you made. So there's not sufficient evidence to conclude that the original claim of the mean evaluation is equal to 3.75. Okay. Questions? So just use that little thing, especially while you're doing the homework and while you're doing quizzes and the mod test. Take the test twice. Make sure that you take notes the first time you take the test so that you can go back so that you can improve your score with that. And the best advice I can give you, I will be doing a review for the final, but I would hope that what you bring to the review for the final is your questions about what you're having trouble with on the review. Because the review, there's multiple different questions. Each time you do the review test, you get a slightly different answer. But the more you do those review tests and the more answers you can do on the review test that you could do without help, the better you will do on the final exam. I guarantee it. So, is there anything else?
No, that helps a lot. Thanks, Professor.
Okay. Rebecca, let's get together and let me go over how to do this with the formulas, okay? And see where you are. What I'll do is we'll pull up your specific homework assignments and let's take a look at where you're actually having problems so that we can work on that. Yes, we did. How do you reject? So if you have a p-value, Rebecca, right up here, If you have a p-value, if the p-value, like in this case, okay, in this example that I have here, p-value was I'm sorry, it wasn't 0.2, it was 0.02. So the p-value was 0.02. No, this was a different one. So if the p-value is less than the alpha being the significance value, then you say that you reject the null hypothesis, or HO. If the p-value is greater than that, then you fail to reject the null hypothesis. Okay? You're going to probably be doing most of yours with critical values because you can use tables to get critical values. If you do your conclusion based on critical values, then you look at the test statistic and you compare it to the critical value. If the test statistic is more extreme than the critical value, then you reject the null hypothesis. If it is less extreme, then you don't. What I mean by extreme is this. Okay? So you draw a normal curve and you write down the critical value. So if the problem is this, it has this in the H1, look at H1 now. If it has this, it's a left-tailed test. If the H1 has one of those symbols in it, it's a right-tailed test. And if it has this symbol in it, it's a two-tailed test. So we'll do a left-tailed test. So your critical value is here. Okay, there's your critical value. If the test statistic is more extreme, because this is 0, if it's more extreme, if it's out here someplace, then we say you reject the null hypothesis. If, on the other hand, the test statistic is over this side of the critical value, then we say you fail to reject the critical value. Does that help? Okay. Anything else that I need to clarify a little bit more? I know everything went a little bit fast, but hopefully, please, if you want to have Paul, this goes for you too. If you want to have a private meeting with me, we can go into this venue and we can look specifically at what you're having issues with.
No, I appreciate that. Thank you so much.
You're welcome. And utilize, as you're doing the homework, utilize the ask the instructor. I try to get back to people as quickly as possible. Not always immediately, but I definitely less than 24 hours.
No, you've been great.
Well, thank you. Thank you, Rebecca. Yes, email me and let's tell me when you're available, and I will try to put that on my calendar to get together with you. Okay, and if we can do it, this weekend I happen to be sort of free, so if you want to get together tomorrow sometime, let me know as soon as possible, and I will plan on it. Okay. Okay, then we'll call it quits for tonight, and you'll see me post another message up there for the next. I'm gonna try to. I think right now I have tentatively. What did I put up? Where's my calendar? If you want to put it on your notes, I've tentatively. I haven't posted anything yet, but I'm planning on doing a final review on Wednesday, the April 24th, or no, that's the wrong one. Final review, 9 o'clock on Wednesday, May 1st. I will be answering people's questions in the final review.
Okay, I'll be there.
Okay. Super.
Thank you.
I look forward to seeing you.
Good night.
Good night. Good night, Rebecca.